everyone, we're Mimicker, here to introduce all kinds of knowledge, even the stuff we didn't know about.
It's great to be back. And today, we're diving into something that, I don't know, it feels a little bit like science fiction.
A little bit.
But it's actually really grounded in the harsh reality of how we communicate. Or maybe how we fail to communicate when things go wrong.
Which happens a lot more than we think. I want to set a scene for everyone. Let's just picture this. It's a humid afternoon. You're in the Taipei Basin. Maybe it's 2:47 p.m. You're on the subway.
Packed in, shoulder to shoulder.
Exactly. And everyone is just glued to their phones. You've got 5G, 4K streaming, people are online, WhatsApp, everything's just flowing.
On a river of data.
And then the shaking starts, a big one. Magnitude 7.8. It's violent, it's terrifying, of course. But then when it stops, something else hits you.
The silence.
Yeah, but it's a specific kind. It's the digital silence. You pull out your phone, to call your family, and you look at the top corner of the screen, the bars are just gone.
No service.
It just says no service. You try to send a message, and you get that little spinning wheel, and it just spins, and then red exclamation mark, fail.
That's the information vacuum. And honestly, that feeling, that panic, it spreads faster than the news about the rubble. We're so used to that feedback loop.
Oh, absolutely.
That little check mark that says delivered or, the map just loading instantly. When that just stops, it's like sensory deprivation. You lose your place in the world.
You really do. Google Maps won't load, so you have no idea if the bridge down the street is even standing. You're completely blind.
And that's because the whole system is so fragile. The fiber optic cables are cut, the base stations lost power, maybe the towers themselves are damaged.
And that's where I want to push a bit. We always hear the internet was designed to be, robust. A military project to survive a nuclear attack, right? So why is my phone basically a brick the second the lights go out?
That's a great question, and it's a really common misconception. The deep backbone of the internet is robust, but the last mile, the bit that gets from the tower to your pocket, that part is incredibly brittle.
How so?
Well, modern cell networks, they use what's called a star topology.
A star. Okay, so everything connects to a central point.
Exactly. Your phone is a little dot on the edge. The cell tower is the star in the middle. If that star goes down, all the dots go dark.
A single point of failure.
Massive single point of failure.
Right.
And even if the tower is still standing, you get congestion collapse.
The classic everyone calling their mom at once problem.
On steroids. Yeah.
Yeah.
A million people trying to use the system at the exact same time. It's just, it's not designed for that. The whole thing just jams up.
So we're efficient, but we are definitely not resilient. Which, I guess, brings us to the actual topic today.
It does.
A technology that sort of flips that whole model on its head. It's called Meshtastic.
Yes. And I like to think of it as a kind of digital arc for when that digital flood hits. It's this community-driven off-grid communication network that, it just doesn't care about cell towers. It doesn't need them.
Okay, so looking at this, it sounds a bit like we're just reinventing walkie-talkies. Breaker 19 and all that. Is that what this is?
I mean, in spirit, maybe. But the technology is it's light years ahead. A walkie-talkie is point-to-point. Meshtastic creates a mesh network.
So not a star, but a web.
Exactly. It builds a web. And in this web, every single device is also a relay point.
So my device is the tower.
You got it. Your device is the tower. Your neighbor's device is a tower. If I want to send a message to someone a few miles away, my device it hands it to yours, which hands it to the next one, and so on until it gets there.
It's like a bucket brigade for data.
That's the perfect analogy. But I know what you're thinking. My Wi-Fi barely reaches my kitchen. How can these little devices possibly send a signal far enough to cross a city?
Yeah, that was my next question.
And that's where the magic of the physics comes in. This isn't Wi-Fi. It uses a technology called LoRa.
LoRa, as in long range.
Correct. Okay, here's the best way to think about it. Wi-Fi is like a cocktail party. It's really loud, tons of data being shouted around, video, audio, complex conversations.
Right, super high bandwidth.
But the sound doesn't travel very far, right? You can't hear the party from 3 blocks away.
Got it. High bandwidth, short distance.
Now, LoRa. Think of LoRa as a whale song in the deep ocean.
Okay, I love that image.
Just this very low frequency, a really slow rhythm. It's not carrying much information at all, maybe just a simple tune, but that sound travels for thousands of kilometers.
So it's quiet, but it persists. How does it do that?
It uses something called chirp spread spectrum.
A chirp. Like a bird?
Sort of. Imagine one of those sliding whistles, that goes woo, woo.
Yeah.
That's a chirp. The signal is constantly sliding across frequencies in that specific pattern. So even in a really noisy environment with tons of static, the receiver can pick out that unique shape from all the mud.
So it's like spotting a bright red jacket in a crowd of gray suits. It's the pattern, not the volume.
Precisely. And that's how you get this insane range. The record is something like 254 kilometers line of sight from a tiny coin-sized battery.
But there has to be a trade-off. Physics always demands a trade-off. What are we giving up for all that range?
Speed. We're giving up almost all of the speed. The bandwidth is minuscule. We're talking like 1 kilobit per second.
So definitely no Netflix.
Oh no, no Netflix, no photos, not even voice calls. It is purely for text messages and GPS coordinates. That's it.
Which, in a disaster, a text saying, "I'm safe at these coordinates," is probably worth more than all the 4K video on the internet.
That's the whole point. It's about utility, not entertainment.
Okay, so we have the whale song. Let's go back to the bucket brigade. How does the message know where to go if there's no central brain? Isn't it just chaos?
It's not chaos. It's called managed flood routing.
Flood routing sounds a little chaotic.
It sounds aggressive, but it's actually quite clever. Imagine you're passing a note in a classroom. You can't just throw it to the corner, so you hand it to your neighbor.
And they pass it to their neighbor and so on.
Right. But in a dumb system, everyone would just shout the message at once. A broadcast storm. It would be useless. Meshtastic devices are polite. They listen before they talk.
They listen.
Yeah. So when your device gets a message to forward, it waits for just a few random milliseconds. And if it hears a neighbor already forwarding that same message,
It just stays quiet.
it stays quiet, it knows the job is done, it prevents everyone from shouting over each other.
That's really smart.
And to stop messages from bouncing around forever, they have a hop limit, like a lifespan.
Yeah.
It can jump, say, 3 times or 7 times, and then it just dies.
It feels almost biological, like ripples in a pond.
It is. And speaking of feelings, this always makes me think of the thrill of getting an ACK,
An ACK.
the acknowledgement. When you send a message out into the void, and then a few seconds later, you get that little check mark. It got through.
You know that specific feeling, waiting for a signal through the static? It reminds me of that movie, Frequency.
Oh, wow, yeah. From 2000
Yeah.
with the ham radio.
Yes. Where he talks to his dad 30 years in the past. Obviously, that's time travel, not LoRa. But the emotion of it, the static, the desperate attempt to connect, it feels the same.
It really does. They're fighting to keep that link open. Here, you're not fighting time, but you're fighting buildings and hills.
Yeah.
And when you get that signal through, it's this little dopamine hit that just says, I'm not alone.
It's about autonomy. But
Oh, wait.
we have to talk about the darker side of this, too. The sources we looked at mention it's being used on the battlefield in Ukraine.
Yes. This is where the story gets really complex. In Ukraine, soldiers are using Meshtastic for off-grid coordination, linking it with tactical software to map positions without using the cellular grid.
Because the grid is either destroyed or, maybe worse, it's being monitored.
Exactly. But this creates a chilling paradox. We talk about radio silence, but there's also your electronic footprint. If you broadcast any signal, even a low-power one,
Yeah.
you're basically lighting a candle in a dark room.
And if the other side has night vision goggles.
They see the candle,
Yeah.
and they can triangulate your position. So the very tool that keeps your team connected could also call in an artillery strike on your location.
So in a disaster, broadcasting your location saves your life. In a conflict,
It can be fatal. It completely changes how you use it. You have to do burst transmissions, turn it on, send data for 2 seconds, turn it off. It's a high-stakes game.
that is heavy. Let's maybe pivot back to some less intense community uses. The data mentioned something called burning mesh.
Ah, yes. Burning Man, the Black Rock Desert.
That feels like the perfect test case. Thousands of people, no infrastructure, middle of nowhere.
It's the ultimate stress test. The cell towers there get overloaded in minutes. So the community sets up these solar-powered Meshtastic relays all over the desert. And suddenly people can text each other, hey, where are you? Or, we need ice over here.
It proves you can just pop up an entire network from nothing.
And it's not just for festivals. Look at what they're doing with Austin Meshed in Texas. It's a city-wide grid. They're all coordinating on the same settings to build a reliable backup network for the entire city.
Okay, I'm sold. I want to build one. I want to join the mesh. But I'm looking at this hardware list, and it's a bit of an alphabet soup. Am I going to waste my money if I buy the wrong thing?
You can, but honestly, the barrier to entry is so low now. If you can plug in a USB cable, you can do this.
Okay, let's do a quick buyer's guide. I'm on a budget. I just want to try it out. What do I get?
You're going to want the Heltec V3. It's the price performance king. It's cheap, maybe 20, 30 bucks, and it has a little screen on it so you can read messages right there.
Is there a catch?
The catch is battery life. It's a power hog because of that screen. It's great for tinkering, but it might only last a day on a small battery.
All right, so what if I want the Prepper Special? The thing I can throw in a go bag and forget about.
Then you want something from Auric Wireless.
Yeah.
They're the power savers. They are super efficient. They don't have screens, so you use your phone, but they can run for weeks on a standard battery.
And for, say, a hiker, someone who needs GPS.
That'd be the LilyGo T-Beam. It's the all-rounder. GPS is built right in, and it has a slot on the back for a big battery. It's a solid all-in-one unit.
Okay, this is great. But now we get to the part where I could accidentally break the law. Frequency.
Yes, this is the golden rule. You can't just buy any board. LoRa uses unlicensed bands, but those bands are different in every single country.
And the sources we reviewed focused on Taiwan specifically.
Correct. If you are in Taiwan, you must use the 920 to 925 megahertz band. So you buy hardware that's labeled 915 or 923. You absolutely do not buy the 433 or 868 megahertz versions common in Europe.
What happens if I do? Did the radio police show up at my door?
I mean, it is illegal, so maybe. But more practically, it just won't work. The antenna is physically tuned for a specific frequency. Using the wrong one is like trying to play guitar with spaghetti. The physics just fails.
Okay, so match the hardware to the region, and I assume there's a software setting for this too.
A crucial one. In the app, you have to set your region to TW or Taiwan. That locks the radio into the legal frequencies.
All right, hardware's in the cart, frequency is correct. Now, flashing the software, that word scares people.
It used to be really intimidating. Now you just go to a website, flasher.meshtastic.org. You plug in the device, click a button on the web page, and that's it. It does it for you.
But the report mentioned one huge classic rookie mistake, the USB cable.
Oh, the curse of the USB cable.
Why is this such a big deal? A cable's a cable, right?
No. So many cables you have lying around are charge only. They came with your headphones or something. They have the wires for power, but not for data. So you plug in your new device, the screen lights up, but the computer can't see it at all. And you spend hours thinking the device is broken.
When it's just a dumb cable.
9 times out of 10, it's just the cable.
And I loved the tip in our source material about using AI if you're stuck.
Oh, it's a game changer. The data we collect shows this is amazing for troubleshooting. You just tell ChatGPT, I have a Heltec V3 and a Mac and it won't connect. And it will spit out a perfect step-by-step guide for you.
Okay, so I've done all that. I'm walking around my neighborhood, all excited, and I only get 100 meters of range. What gives? I thought this was long range.
And here's the reality check. LoRa is line of sight. Those radio waves, they act like light. They do not like going through concrete buildings. If you're on a city street, you're in a canyon, the signal just dies.
So how do you fix that? How do I get those crazy long ranges?
There's a mantra in the community. Height, height, height.
Hi, guy.
Get the antenna high.
Yeah.
Moving your device from the basement to the roof can change your range from 200 meters to 10 kilometers. It is that dramatic.
And that leads to this idea of solar repeaters, right?
The set and forget method.
Yeah.
You take a low-power RAK node, put it in a waterproof box with a small solar panel, and you stick it on top of a tall building or up on a nearby mountain.
It becomes a community lighthouse.
That's exactly what it is. It creates this permanent umbrella of coverage for everyone. Your little handheld device down in the canyon can just shout up to the lighthouse, and the lighthouse shouts it out to the rest of the city.
I love that. You're building your own public infrastructure.
It's powerful. But, we should be clear. This is not replacing the internet. It's not for TikToks in the apocalypse.
No TikToks.
No, but that's not the point. The point is resilient. It's like a fire extinguisher in your kitchen. You hope you never, ever have to use it.
But when the big one hits...
When it hits and your phone says no service, knowing you have this little box in your bag, it fundamentally changes your mindset. You're not a victim of the silence anymore. You can break it.
It's about reclaiming that right to connect, owning a piece of your own communication network instead of just renting it.
And even without a disaster, there's just something so satisfying about sending a message through the air with just physics and community goodwill and seeing that little ACK light up your screen. It reminds you that you can build things, not just consume them.
That is a really powerful thought to end on. It's about taking back a little bit of control.
Exactly.
Thanks for tuning in to this episode. If you enjoyed our content, don't forget to like, subscribe, share, and turn on the notification bell.